This is a production of Cornell University.
All right, hi everybody. My name is Savanna Shelnutt. I'm a second-year master's student in Larry Smart's program, and really my work over the past several years on evaluating different hemp production systems for New York State. So first year I looked at high-density plantings, direct-seeded high-density plantings. Last year I was involved with a project sponsored by the New York Farm Viability Institute, and we were evaluating the economic production differences between high tunnels, the outdoors, and greenhouses. And during that trial, we noticed that there was an elevated incidence of powdery mildew in our tunnels. And in order to make high tunnels a really easily manageable system in New York State, we decided to come up with a little fungicide trial to determine what works best for us. So my advisor, Larry, knows somebody from Utah State, and he stated that they thought that applying wollastonite, which is a silicon crystal to the soil, might enable us to easily control powdery mildew in our tunnels. And the idea with that is that you apply the silicon one time or twice a year, and you just leave it in the soil, the plant uptakes it into the leaf, and you don't have to worry beyond that. So we decided to use a soil-applied silicon treatment. We also have a foliar treatment, which is Sil Matrix. And then we wanted to use a popular biological control, so we went with Millstop and Cease. And then we also have Trigo, which is a conventional fungicide. So the reason we chose this layout for this trial is we were initially thinking that we would apply the wollastonite or the Vancil twice in the season, but after some further evaluation we decided we just wanted to do it early season. So that's why the soil is exposed in the plots, because we wanted easy access to mix in the wollastonite throughout the season. Additionally, there's wide spacing between the plants because I come through here once a week and I rate each plant for its powdery mildew incidence. So if the leaves are touching each other or the plant's all crossed up, it's difficult to rate for powdery mildew. So that's why we chose this 4-foot spacing between plants. And we opted with white landscape fabric just to try to keep the heat down in here. I don't know if you've noticed, but it's much hotter in here than it is outside. It's about 90 degrees in here, and it's in the mid-70s outside. And also I have this exact trial replicated in the grow dome. In the grow dome, it's probably about 95 degrees right now, so it's very warm in there. So powdery mildew, as Allie and Chris were talking about earlier, it is a fungal pathogen of hemp. And basically how powdery mildew works is that the conidia land on a leaf and it generates a hirsutia, which is basically a little root-like structure that penetrates down into the leaf and acts as sort of, you can think of it rudimentarily as like a straw, and it sucks the nutrients it needs up into the host cell. And so the idea behind applying silicon to the plants is that silicon is an important constituent of plant cell walls, and it helps to strengthen the cell wall. And so if there's a high level of silicon in the plant cell, in theory you would think it would be more difficult for the powdery mildew to penetrate into the plant. So these plants, we started them in the greenhouse middle of May. They were allowed to grow for 4 weeks. We transplanted them out, allowed them to grow for 5 weeks vegetatively. And then we came in and inoculated and sprayed all of our treatments for the first time the day before we inoculated. We inoculated about 4 weeks ago, and we've been rating and spraying weekly since then. If you are curious about the rates that we're using, you can use the QR code outside to pull up our sheet here. Yep. And so, yeah. So just a little information on how the different products work. Millstop and Cease. Millstop is a sodium bicarbonate, and that works by altering the pH of the leaf. So fungus really likes low pH environments, so it likes more acidic environment, and sodium bicarbonate is basically baking soda. It elevates the pH of the leaf surface and makes it difficult for the powdery mildew to grow, and that's mixed with a strain of bacillus, which is Cease. Cease forms a biofilm on the leaf surface and makes it difficult for the powdery mildew to establish itself because it has to compete with another living thing on the surface of the leaf. And then we have Trigo. That's a more conventional option there. It's actually only labeled for ornamentals, so since we're not using these plants we're just looking at them, it's okay to use. And we chose that because we wanted to prove that we could effectively control powdery mildew in the tunnel. And that works by inhibiting the respiratory pathway of the fungus, so that means that it's more difficult for the fungus to create energy when it's on the leaf surface. So far, we are 3 weeks into this project, and as you can see, we have plenty of powdery mildew germinating on our leaves. We chose the cultivar white CBG because it's known to be highly susceptible to powdery mildew. And I invite you all to walk around and look and ask questions. You'll notice that there are some differences between the different treatments. This treatment, so each row of plants is a replicate, and so this row right here is labeled very simply so you can see what it is, but if you want to walk around and look at other plots, if you look on that end of the plots, there's a yellow tag. Yeah?
Did you start grow dome the same time as the high tunnel?
Yes, yeah. So, yeah. I don't know, I invite you all to look at the high tunnel, or at the grow dome. Some of the plants in there are over 8 feet tall, so just check it out. Yeah, so just feel free to walk around, look at the plants, ask me any questions you might have. You can go ahead and you can notice some differences between the different treatments. There's nothing concrete right now, but I mean, obviously the trifloxystrobin Trigo is working great. Everything else, there is a little bit of powdery mildew here and there. So,
hey, Savanna, a couple of people have asked me 2 questions. One, did you start these from seed or cuttings before bringing them out? And the other, why do you think the plants are such different heights?
okay, that's a great question. So, question is, did I start the plants from seeds or cuttings? So this is all started from seed, and as we know, when you start from seed, it's a mixed bag. You hope that your plants are stable, but sometimes they're segregating for different traits. So another question is, why are my plants different heights? So if you stand out back here and look, you'll notice that those plants are pretty stunted. These plants are fairly stunted. These are okay sized. That is because a week after we planted, the sides of we hadn't had the sides programmed correctly at the time, and it just dumped rain and flooded those outside plots, and it took about 2 weeks for them to dry out. So yeah, that is from water flooding, stunting, right there. And then within the plots, you might notice some variable height. This population of plants is segregating for flowering time. So some of the plants started flowering about 3 weeks ago, and some of them just started flowering this week, and a few of them you'll notice haven't really quite gotten there yet. So obviously when the plant begins to grow, starts to flower, it ceases its vegetative growth. So that's some of the variable height within the plots. Any other questions real quick? Yes. Yeah, so the question is there any anticipated post-harvest issues, quality issues with the silica? And so we have taken leaf samples from all of our silica plots and the control plot. We're going to compare what the level of silica is in the control and in the leaf, the foliar applied silica and the soil applied silica. And we should be able to evaluate if it's at a safe level from that point, and also evaluate how well the plants are able to take up the silica. And we spray the silica, the foliar silica, weekly. We spray it, actually we're going to continue to spray it throughout the extent of this study, so well into flowering. Yes?
Hi. What do you think is a contributing factor to the size difference in between here and the dome?
All right, this is a great question. So the question is, what do I think the contributing factor is between the size difference here and in the dome? And the answer to that question is, so we have, okay, if you look back here, there's a little funny looking arm situation, and that black thing on top is a PAR sensor, and we also have a PAR sensor in the grow dome. So one of the main things I think is that it's much warmer in the grow dome than here, and obviously the plants are really enjoying that. The second thing is that the PAR in this area is, there's more PAR is plant available radiation, so that's how much radiation is available for the plant to photosynthesize. PAR is higher in here just by nature of the fact that this is a clear plastic and the grow dome's covered in white plastic, and if you look in there, there's a greater internode length, and usually when the light level is low, the plants will stretch more to obtain more light. So I think it's a factor of the fact that it's much hotter in there. The plants are very happy with that. Also, there's greater internode length because there's less plant available radiation. Any other questions?
Savannah, I have a question.
Yes.
A question about the Trigo mainly.
I know that that's labels that it's a systemic and you can go up to 28 days between applications on that. So did you go that length? Did you see better results with Trigo, and was there any phytotoxicity?
Great question. So the question is Trigo, which is the more conventional style fungicide. It's labeled, you can wait between 28 days to spray the next round of that. And have we seen phytotoxicity, and what have we done? So we opted to go for a 2-week interval with our Trigo, and we haven't noticed any phytotoxicity yet. We've only sprayed it twice at this point, but we will be noting if there are any effects from that. And it has had excellent control so far. I haven't seen any powdery mildew on any of our Trigo plots at any of the 4 locations where this trial is replicated. Any other questions?
How will you publicize your results?
That's a great question. I'm not sure yet, but I'm definitely sure that there will be a link to it on the Cornell Hemp website, so feel free to check that out, and maybe Larry will tweet about it when it comes out. So, or Chris. All right, any other questions?
Have you noticed the difference, like, temperature-wise, if there's more or less powdery mildew?
Yeah, that's a great question. So one thing that I didn't go over that's really important is that powdery mildew really enjoys it when it's warm, when there's low actual wetness, so it doesn't like a lot of rain, but it likes it when it's very humid. And so it does enjoy this environment because it's warmer than the outdoors, and also because it doesn't rain on the leaves, and because there's high humidity in here. And powdery mildew also really likes it when there's a strong binaural fluctuation in the temperature, so when it's cooler at night and warmer during the day, and in here it does cool off at nighttime, so it enjoys that aspect of this environment. Yeah, so that's the answer to that question. Any other questions?
Before Savanna finishes up, Larry asked me to remind you that there is a failing demonstration at the Research North Field that starts at 2:30, and I'm sure several cars will be going that way.
This has been a production of Cornell University, on the web at cornell.edu.